Okay, so let's just take a quick look at one more Java secure coding rules. So this is about exceptional behavior, okay? So how we correctly use exceptions, the try-catch block. So the first, let's take a look. And I'm not sure if you all still remember the exceptions when we discussed. There are two types, that unchecked exception and the checked exception. So for unchecked, then it's not mandatory, as it you need to handle it. So the compiler won't complain, but for checked, you must handle it, okay? And so the first rule in exceptional behavior in the ERR1, the sub rule is regarding the checked exception. So previously we already know that you cannot ignore that, and here says you cannot suppress or ignore checked exception. Okay, so be careful. You must handle it. So there are, you either catch it, okay, or you can throw it and leave some other method to handle it. So that's just a general rule. And here it gives an example. And if you recall the IO exception, it is checked exception. Checked exception. Here you may say, oh, we did catch it. We did handle it. Is it? But there is a problem here, is you're going to print the stack trace of this checked exception. Okay, and it says this printing the stack trace, it's useful for debugging purpose. But when you release like your code that for some party to use, then if you do the print stack trace, because at that time it's applications not in the development phase. So if you still keep the debugging activities on, then as a resulting program execution, then equivalent to suppressing the exception. Is it? And also, you printing the stack tracing, it can also leak some information about the structure and state on the process. And then an attacker may take advantage of this. Later on, we will also see another rule is we shouldn't allow exception to expose sensitive information. Okay, so if you just do print a stack tree, that's not a good idea. Okay, even though you say, okay, I handle it, is it? So the recommended, like in this case, for file handling, is it? So file handling, like a file not found exception, is also checked exception. So for the checked exception, then in the catch block, is it? What you can do is you ask a user, you can do some interaction. You ask a user for try a different file name. Okay, so this case, then it will comply. Okay, so that's just a recommendation. Okay, and then let's move on to the next one. The next one is just following, if you recall the previous discussion, is that for the exception, we also shouldn't allow exception to expose sensitive information. Okay, so that's also a rule. Even though you try to catch and handle it, but don't expose sensitive information. Okay, and here it also lists. So this is a pretty useful table. Okay, it give you exception name, and it also gave you some description about the information may be leak or threat. Okay, like a file not found exception. That there may have potential to expose the file system structure, username, etc. Okay, later on, like for advanced Java, if you do database application, the SQL part, then that can also expose the database structure. So that's also not a good idea. Okay, and some other thing like over here, it can also invoke the denial of service, okay, attack. So like over here, Stack Overflow error is a denial of service. So we shouldn't expose the sensitive information. So here it gave us an example. Okay, so this is in main, is it? And for the checked exception, so file not found exception is a checked one. So over here, we don't have the try catch block to directly catch the file not found exception. Basically, we just let the main method throws it. That's also fine, is it? So the compiler won't report error. So your program can be compiled, but there is potential, okay, because over here, so you are going to, you use the file input stream, is it? And you plug in. So this app data basically is used to store users' home directory, is it? And this is in Windows. Okay, so it's kind of, you can get some sensitive information, is it? This is more related with users directory, home directory. Okay, so that's not a good idea, because it says when a requested file is absent, then it will throw this exception. And these exceptions that allow an attacker to reconstruct the underlying file system. Okay, it says by repeated passing fictitious path name to the program. So this can cause some serious problem. Okay, so that's not a good design. And here it shows more. Okay, so over here you say, okay, I catch it, but then you throw another exception. Okay, so that's also not a recommended approach, because you wrap and re-throw sensitive exception. Okay, exception. So that's not a good way. And here it also shows, it says non-compliant, is it? And then you throw the security IO exception, is it? So even though you log the exception, but then you throw one, and this one that does not wrap the file found exception. Okay. And then what is the recommended approach. So let's take a look here. So the recommended approach here is we can try to use the canonical approach. Okay, so file system has a method, okay, called get canonical file method. And this method can simplify the subsequent path name. So it can simplify. Okay, so what over here is, because you do want to get the information about the home directory, is it? Then what you also do is you also pass in this get canonical file method. Okay, and then you are going to do some check. And over here, then you try to catch the exception. Okay, then you said, okay, that's not invalid. If it's good, then you can move on as to take care of your file. Okay, but for the file handling, you always need to take care of the check the exception. Then you just give some output. Okay, so this is a way to handle it. Okay, so that's regarding the second rule. Then let's take a look the third rule. So the third rule is a prevent exception while logging data. Okay, so what over here says exceptions that are thrown while logging is in progress. It says can prevent successful logging unless special care is taken, etc. So over here it says this non-compliant code write a critical security exception to the standard error string. So that's what this part try to do. Okay, so this is a not compliant, and what it recommend, because that's kind of you just output to the screen, is it? So what to recommend is you use Java utility logging logger, okay, to do the logging. So what over here is recommend is you do this logging and logging and you keep track of the exception. Okay. So that's the third one. And then the next one. The next one is recommend to restore prior object state when method fail. Okay. And what this means is in object-oriented program, objects, is it? So objects, especially in security critical objects, they must be maintained in a consistent state, even when exceptional condition arises. Okay, and there are some recommended approaches that you can achieve the goals. One is input validation. Okay, and the last class we also discussed, is it like method arguments? Okay, you need to validation. And then the other approach is you reorder logic so that the code can result in the exceptional condition execute before object is modified. And in the event of fail, you can also roll back. Okay, and the other way is you perform require operation on a temporary copy. Okay, and you do the changes on the original only after the successful completion. And you can also avoid to modify the object at all. So this is about how we keep the state, object state. Okay, so let's take a look at an example here. So this example is regarding some dimension. You have length, width, and height. It's kind of like for GUI design, is it? You have length, width, height for like maybe 3-dimensional, is it? But you also have padding, okay? And you also have maximum. So this is padding. That's the maximum dimension, length maybe, okay? So you can define something like that. And then, so what over here, okay, this is pretty straightforward, just a constructor. Then for this specific method, is that get volume, okay? The parameter you pass in is a weight, okay, the weight. And the very first step you do when get volume is you consider of the padding, okay? And then within it, so here we have this try-catch block. Okay, in the try-catch block is we have some condition check. In the conditions, if the length, width, or height less or equal than padding, or greater than the dimension, maximum dimension plus padding, or the weight is a negative number, or weight is too large, okay, then you are going to throw this exception, illegal argument exception. So this illegal argument exception then is going to be caught, okay, by this catch block. If everything is fine, then you do volume calculation and we roll back. Okay, so here we roll back the length, width, and the height. And then you calculate the volume, is it? So that's what this part does. You may say, oh, it looks all right, is it? But then let's take a look. So here you have a dimension, object created. So it's all fine, length, width, and height, okay? And then you call the get volume. What you pass in 21. 21, then let's take a look. So 21 is greater than that. Is it? It's greater than that. So you're going to throw exceptions. You're going to do the catch exception. Is it? But here the problem is all the length, height, and width. So the instance variables already modified to a new state. But basically, you see, because this part is skipped, is it? So no rollback. No rollback occurs. Okay, and okay, no rollback occurs. So over after you execute this, it prints some wrong information, is it? But your dimension is not 8 by 8 by 8 anymore. Is it? It's changed to a 10 by 10 by 10 now. Okay, so then next, when you do the get volume package, you pass in 19. Is it? You pass in 19. Then the length and width is all updated to 12. Suppose to be 10, is it? But this is going to 12. So then your volume calculation is wrong. Okay, so this shows the inconsistent state when you design your object. Okay, so there are some recommended way we can do compliant solution. One is called rollback. Oh, rollback is if something is wrong, is it in the catch block, you do the rollback. So this is one approach. The second approach is you provide a finally block, and the finally will always do the rollback. Okay. And there is another way. It's you're going to use input validation. Okay. The input validation. So this part take care of input validation first. So input validation first. Is it? Then update object state. Because if this part, if fails, is it? Then it won't go to the update. So it will not cause problem. So this kind of design is recommended. Okay, so when you do need to do input validation, then you always do input validation first instead of update object state. Okay, so always keep this in mind also. This is also kind of a design recommendation. Okay, and there is some other way is that you don't modify object. Is it? So then the recommend, because you're just going to calculate volume. So why do you need to update the length width? Is it? So why you don't just do that? This is also strongly recommended. Okay, so just be careful, okay, whenever you design some class. Okay, then next, let's take a look. The next rule. The next rule is regarding the finally block. The finally block, then we also need to be careful as do not complete abruptly from the finally block. So what is recommends, never use return, break, continue, or throw statement within finally block. So keep this in mind, okay? Don't use return, break, continue, or throw. Those keywords in finally block. Okay, so let's take a look at this example. So here you have that try, then you have this finally, then you do the return statement. Okay, so it says then this exception basically is suppressed. Because whenever you have exception, you try to do something. Is it to handle the exception? But here basically you didn't. You just return. Is it? So that's not recommended. The recommended way is you have exception, is it? The finally you take care of it and over here for the return statement. So the return statement, put it outside of try, catch, and finally block. Okay, so that will be more applicable. Okay, so it says applicable only when exceptions thrown conditional. Okay, so just be careful about the finally statement, the finally block. And also it says do not let check the exception escape from a finally block. Okay, so then let's take a look in this case. So this is non-compliant. Okay, so over here it says in this example, the finally block close reader object. A reader is IO. Is it IO? It says the program incorrectly assumed that the statement in the finally block cannot throw exception, and the concept fails to appropriately handle any exception that may arise. Okay, and so in this case, so you have a try, then within the try you have another try, is it? And here you take care of that. But this reader that close, it may raise exception. Okay, so finally block, then it didn't take care of that case. It can also throw an IO exception. Okay. Okay, so what I recommend you do is then within the finally block, you also take care the exception when you try to do the close. Okay, and if you recall because this all involved file resource. Is it? And for any operating system resource, you also need to remember to close it. Whenever you open, then don't forget to close it. Is it? So that you resume the resource back. Resource back to operating system. Okay, whenever you don't need it anymore. So here it's recommended within the finally block, you also take care of the possible exception. That's also why we also have the try with resources, if you recall. Okay, so you can also use with try with resources. So here we do try with resources. Oh, here. Try with resources, is it? So you put the opening statement within the try, parameterized as like the parameter part, okay, like the plugin, and then you catch the exception. Okay, so you can use try with resource, then you don't need, so no worry to close resources anymore. Because the try with resource will automatically take care of resource reclaiming back to system. Okay, so we don't need to worry anymore. Okay, so that's, so a lot of time if you have like file handling or network handling, you can use the try with resource, okay, so that you don't need to worry about handling the closing resource part. What the next one recommend is do not throw undeclared checked exception. This one, okay, this one, let's just skip it because it's some information we haven't learned, okay. And what next one discuss is do not throw runtime exception or throwable. Okay, so let's take a look what this is. So that's the specific one, is it? So in this case, this is for some null value checking, is it? Then you throw some runtime exception. Okay, you throw some runtime exception. And what the problem with this is the calling method violate the do not catch the null pointer exception. So that there is another rule about null pointer exception. Okay, because this is just deal with null values. So that's not a nice way to do it, okay? So the exception you throw is a null pointer exception. But even with null pointer exception, normally if you recall in our lectures, we said normally for null value, we don't recommend to use null pointer exception. Okay, that's kind of overkill, okay? So, but anyway, this is fine. If you do, okay, this is null value, then you throw null pointer exception, okay? But normally we don't recommend the null check using a null pointer exception. And also, so for this, it's just a throw exception. Okay, throw exception. And a lot of times, if it's deal with input output, it's checked exception, then you can specifically. So don't use the too general one, is it? Because this is a root level. Okay, so. Okay, so that's just regarding the do not throw the runtime exception. Okay, exception or throwable. So get to more detailed information. Okay. And what the next one, try to explain the rule is do not catch null pointer exception or its ancestor. Okay, so let's take a look. So that's for null value, generally what we recommend. So over here, it's deal with string, is it? So string, sometimes you may have null value. Then you say, oh, I use the try catch to take care of null pointer, is it? Well, that's kind of like previously I explained, that's overkill with the catch null point, so it's overkill. Okay, with the null pointer exception. So normally what we deal with, you can just explicitly check against null, and then you just handle it. Okay, rather than you catch that null pointer exception. Okay, and over here it shows another compliant. Then in this case, you didn't do the check, is it? Then this approach itself, it will throw no pointer exception. Okay, because anyway, this is not a checked exception. So not checked exception. So that is fine. Okay, then it will be able to be thrown. Okay. Okay, so that's regarding null pointer exception. Okay, and also the last one in this exceptional behavior rule is about do not allow untrusted code to terminate the Java virtual machine. Okay, so over here it just shows that you call the system data exit and one, then this can abruptly exit. Then this part will never be executed. So this, what it recommends is you can do some checking. Is it? You do some checking, okay, and then you do some security checking. Then you use some flag, and then you have provide some method to get the flag. Is it? And if it is allowed, then you can exit. If not, then you don't exit. So then in this case, is it? So you can, so we can do the checking. Is it? Do the checking and then, so if it is meet the exception, meet the security check. Okay, didn't meet, then you can exit. Is it? Otherwise, you won't allow it to occur. Okay, so then this will take care of the abrupt exit, because then it when other party use it, they won't have any clue, is it? So that's why over here we allow the exception, the exit, and then you let the system stop working, is it? Because whenever you call the system dot exit, then that Java virtual machine, it will be terminated. And why we say we needed to be careful is because when you have server application, is it? You don't want the server be abruptly terminated. Assuming like the web server, is it? So normally if you want to stop the server application, before that, you need to have some procedures, security procedures to check if it is a good time to terminate the application, is it? So because Java used a lot at like a mobile app or web app as a back-end application. And when we said a web application or mobile application, and normally the backend, it involves some kind of server application, and you write Java code. And if we don't pay attention to this exit call, then terminate abruptly, then that's not a good design. That we want to have certain level of security check, then we stop the application, okay? Because this can also avoid the denial of service attack, okay? So, because otherwise it's going to be too easy for denial of service, etc. So some attacker then can take advantage of the system data exit, etc. So bring the server down, okay? Okay, so that's the general idea about Java security.